Hello everyone. In this video, you're going to see how to create a model in eMotor Director and run it. To open eMotor Director, you need to go into eMotor Director installation folder and then open launch emd.bat file. And this will start to open Pulse and which will open the main window where you can start using eMotor Director. And this is how the window for the Pulse looks like, and you will see a tab for eMotor Director. Once you click on it, you'll be able to see multiple options to create project, explore, etc. So here you'll click on new project, give the project name, and once you give it, we need to select the CAD so that you can import it into eMotor Director. So to do that, the first thing you need to give the path where the CAD for the motor is stored. So for this example, I'm going with the test files that is coming with eMotor Director. So I'm selecting that folder here. And for the CAD format, I'm going with Flux, but you can select Flux motor geometry also. And then for the CAD input director, I'm selecting the CAD model folder as in the video, and then you can see multiple geometries that are there. So I'm selecting the first one here, and then once you click OK, that will come in here. Now you can explore the project. So right click on the FLU and click on View and Organize. This will open the hypermesh and it will display the geometry for you. Once you have it here, you can see how the rotor and the stator parts are looking like. And here just click on yes on the pop-up. And here you need to make sure about number of magnets, the parameters for the rotor, outer and the inner diameter, and then number of poles and the and then the nose in the model and then the corners. And once you have that, then you need to enter the yoke face component. So to do that, you need to select the yoke face component and then click OK. You need to make sure whether the symmetry for both the magnets in the rotor are correct or not. So for example, the component 2 is in symmetry and the magnet component 4 is not in symmetry. That's what 4 is away from the symmetry and the other one is towards. And once it is okay, click on OK and say yes. And yes, you wanted to add it to the newer data, so just click yes to go and then close it, close hypermesh 1. Just save it as a new session in the folder where you wanted to run the study in the eMotor Director. And once you save it, you can go back, you're ready to go back to the eMotor Director and continue with the setting up the model. Now, once you're back into eMotor Director, you can see there'll be a new study on the left-hand side and then all the types of tests available on the right-hand side. So to start with, you can click on and drag it into the center, the working point simulation or the base point run, and then the efficiency computation. Now you can connect both of them so that uh, the inputs from the base point one is linked to the efficiency map computation. Now you can go into study settings, give the temperature for each part, that is the magnets, windings, and then the other ones are giving the maximum line current, line to line voltage, and the maximum speed at which you want to run the model. And then moving on to the motor design, there are a couple of parameters for the stator, rotor, and the length. These are like the outer dimensions. And then you'll see the inner dimensions for the stator and the winding that are already brought into when you imported the part. And then you'll have couple of other inputs needed for the base point run and then the efficiency. Now you need to select for which parameters you wanted to do the parameter runs, and then so you can select it so that these will be used when you're doing like a design of experiments or an optimization. So you can select the parameters in here. And also you can select how many number of current values you want it to be considered for the working point, and then number of current values, computations for speed and torque points for the working point, and then for the efficiency, solver steps. Mechanics are considered when current is not sinusoidal. And then moving on to the responses. These are nothing but the outputs that you wanted to see or analyze when you run the working point and also the efficiency map. So we have moment of inertia selected, magnet mass, conductor mass, and then in under the working point condition, so we are selecting that need to be given as an output as a response, and then even we'll select a couple of them for the efficiency map. So for the working point, we have torque, losses, and then the input parameters. And for the efficiency map, we have the losses, power, selected torque ripple. And now we are ready to do a nominal run. Need to go into run and now select to create a new run. So how many, based on number of design variables can be, is number is already set up in there. If not, you can change it. And then the number of responses that you selected as outputs, and the number of runs. This is for the DOE, but for the nominal run, it's just one run. So once you click on do DOE run, so this small window appears and it will start to run. You see, once it starts, it gave the two geometric parameters that you selected, and then now it computed the mass that you requested for, and now it's running the nominal run. So this is the waiting symbol, but once it completes, it will give you the values in here for the current torque losses. And now you see the run is completed and you can see all the values for the torque, joule losses, iron losses. And now the efficiency map computation is also completed and the responses you requested for are also listed in here. So for further analysis, or if you want to look at it in detail, just right click on the success and click on open e-motor results right here. Yes. And once you click on it, the flux motor report will open for you where you'll have all the detailed analysis given and then you can analyze more in detail. All the test results will be given in here. It's the same report that is created in here with all the maps and the outputs included for you to further analyze. And in addition to the flux motor, if you wanted to look at flux project, then you can directly go into under efficiency map. You can click on open EM results advanced to open a flux project. And now you can run DOE with the same settings. So for that, you need to close this pop-up window, and then if you wanted to see more, if you wanted to do DOE on more variables, you can select it here and then select more responses that you need, which are helpful for your design of experiments that you wanted to run. Now here I just added stator joule losses also. And once that is done, you can go into run, and here you can select again how many number of runs for the DOE you wanted to do and how many number run. Now click on DOE run. Now this will, you see all the 7 runs that you requested for is seen in the table, and now it start to run all of them. And as the progress you see for the nominal run, it's the same process, but it will run 7 levels. And you'll be able to see all the results for all the and all the responses that you requested for that variation of the geometric parameters that you have selected. And here it's running the second one. It completed almost 6 runs, and now after 7 runs are completed, you can see all of them. Now with all the 7 runs, you can see all the test results, the responses you requested for. And this is how you can set up a model, do a nominal run, and DOE in eMotor Director. Thank you.